Hi again everyone, Dr. Tom McNamara here for our course in trigonometry. In this video we are going to discuss using some properties that the trig functions possess, namely that some of the trig functions are what we call even functions and some of the trig functions are what we call odd functions. Okay, so a couple of facts. Cosine of negative theta is equal to cosine theta. Cosine is an even function, okay, what we call an even function. And just a quick background note here. Even functions are symmetric about the y-axis. Okay, so the left-hand side of the graph is the mirror image of the right-hand side of the graph when you're dealing with these even functions. And y equals x squared is a prototypical even function, and you can see the evenness in this property right here. If you take a negative number and square that negative number, you get the same thing as if you would have just squared the positive version of that number. And that's what gives you the symmetry here. The height of the graph at x equals 3 is the same as the height at x equals negative 3. And this would be true for x squared, it would be true for x to the 4th, x to the 6th, etc. That's actually why we call it an even function. Okay? Even powers have this property, and so do some other functions, like the cosine function. So if you take the cosine of a negative angle, you're going to get the same result as if you had taken the cosine of the positive version of that angle. Okay, so that's fact number one. And the other fact that we're going to make use of is that the sine function is odd. Okay, so cosine is an even function. And if you look back at the graphs, you'll see the graph of cosine has the left side and the right side exact copies of each other. But if you look at the sine function, you'll see it's actually an upside down copy. The left side and the right side are flipped. And that is coming from the fact that sine is an odd function. Okay, so if you ever see cosine of a negative angle, you can replace it with cosine of the positive version of that angle. If you see sine of a negative angle, well, you got a negative outside now. Okay, so let's do a couple quick examples where we make use of these facts that I put right up here. Okay, so let's go ahead and evaluate, oh, I don't know, sine of negative 5 pi over 6. All right, so using my identities here, this should be negative sine 5 pi over 6. Okay, so negative sine 5 pi over 6, and using my unit circle, I can see that sine of 5 pi over 6 is 1/2. So this works out to be negative 1/2. Okay, let's try this one. Let's do secant of negative 150. All right, now you'll notice my two facts here involve sine and cosine. I didn't say anything about secant. But of course we realize that the reciprocal identities can come into play. Secant is the reciprocal of cosine, and by the rule we have right here, cosine of negative 150 should be the same as cosine 150. And we can use our unit circle there and see that cosine of 150 is negative root 3 over 2. Okay, that's what we have down here in the denominator. So negative 2 over root 3. Okay, so two quick examples of evaluating trig functions making use of the even and odd properties of sine and cosine respectively. Another area where this property or these two properties are useful is working with identities. So let's go tackle an identity where we make use of the even and odd properties. I'm just going to pull one out of our textbook right here. Okay, so let's prove that this is an identity. So prove sine negative theta times cotangent negative theta is equal to cosine theta. Okay. Now remember, when we're working with an identity, we of course need to show our steps. We need to show the steps that we would take to transform this side into the right-hand side. And the strategy that I follow is I want to write everything in terms of sine and cosine. So in other words, I want to replace the cotangent. Okay, so I'm going to start with what I have on the left. Sine negative theta times cotangent negative theta. That is equal to sine negative theta. Now cotangent negative theta, I can replace that with cosine negative theta over sine negative theta. All right. A big mistake that I see a lot of people doing is writing down this side way too early. No, first step, left-hand side, then do your rewrite. That's the next thing. You have no justification for saying this is equal to cosine yet. You haven't established that. Okay, so we got this. Now, our next thing is, well, we know we can replace negative sine for sine of negative theta. Okay, we can use the odd property, negative sine theta. In fact, you know what, I'm going to be a little more clever than that. Those can cancel out right away. Okay, so we're left with cosine negative theta. And now we use the even property of cosine to get that that is equal to cosine theta. So we took the left-hand side, we did our algebra, we showed that we can transform the left-hand side into the right-hand side, establishing the identity. Okay, so two uses of these evenness and oddness properties for sine and cosine. One is actually evaluating the functions. Another one is this comes up in identities sometimes. It helps us simplify things. Okay, so cosine of negative theta is equal to cosine theta. Sine of negative theta is equal to negative sine theta. Two important facts about the trig function.